Hello, welcome to running CentOS 6 in 2025. I'm just kidding. That's not what the real presentation is. This talk is about running CentOS Stream in production, a case study in boring technology. So before we get any further in the presentation, I work for a small energy company located in Houston, Texas. My supervisors and my directors have asked me not to divulge the company name or the logos or the likenesses of anything about that. So you will see some slides that have redacted information. It's not related to federal government stuff. It's just I've been asked not to put like actual company names and anything. So that's why things are going to look a little odd in this presentation. Just letting you guys know up front. So moving on. Who am I? I'm Robbie Callicotte. I am DevOps team lead at aforementioned small energy company. I'm a contributor to the Fedora package ecosystem. I maintain approximately 100 or so packages within Fedora and EPEL. I'm also in the EPEL steering committee. We have weekly meetings where we discuss EPEL policy and how new packages can be added, removed, and what have you in the ecosystem. I'm also a member of the CentOS Alternative Images SIG. We provide images like the KDE CentOS stream image, the LXQT, and so on and so forth. So, a brief history of CentOS at this moment. Is everyone familiar with CentOS Stream thus far? Okay. I maybe won't spend too much time in going into the particulars of this, but essentially CentOS started in 2004 as a free clone, freely available clone of RHEL. I believe the first release was CentOS version 2. If I'm wrong, just let me know. Throughout its life cycle, there were periods of time where the CentOS release was not provided in a timely fashion. I think the big one was CentOS 4, where there was a 2-year gap. It was 5. Thank you, Brian. CentOS 5, there was like a couple-year gap between the RHEL release and the CentOS release. Red Hat graciously stepped in 2014 to provide sponsorship for CentOS. In 2019, Chris Wright announced the update for CentOS Stream. And then Rich Bowen, who used to be the community, the community maintainer for CentOS, released the article, The Future of Stream, basically announcing the end of CentOS Linux as a distribution and the forward movement from that point forward as CentOS Stream as the distribution. I would be remiss if I didn't mention that the ecosystem has changed since that announcement. So now we have a plethora of other available enterprise Linux clones. Alma, Rocky, of course, OpenSUSE, Oracle. The OpenELA is an organization basically comprised of CIQ, SUSE, and Oracle, just as another governing body around enterprise Linux availability. How many of you have seen this before? Okay, well, I know you've seen it. I know you have. The relationship has changed. Some would say that top row does it have a laser in this? Is there a laser in this? Anyway, some would say the top was that's the way it operated before the CentOS Stream project worked. And some would say that was the preferred way. It now operates in this fashion. So you have Stream sitting firmly between Fedora and Red Hat in the release cycle of the packages. In my opinion, this is the way that it should have always operated. That's my personal opinion. The reason being is you now have full community cooperation at this point versus the way it used to operate. So how many of you have seen this slide? Oh, thanks. I might. So this is just another slide that goes into a little bit of detail on the contribution and the life cycle of CentOS Stream and how it relates to RHEL. Also have to apologize, I'm recovering from COVID and bronchitis, so my voice may be a little hoarse and I might be coughing a bit, so apologies for that ahead of time. So, what I'm trying to wrap this into is I'm trying to let you guys understand how we run CentOS Stream at my company in production. So I'm going to lay a little bit of groundwork on our philosophy of how we manage the systems, how we handle packaging, how we handle updates, basically how we operate the equipment. So this is something that I haven't really seen in a few years at other places that I've worked growing up. Internal mirroring was like a de facto standard. And at some point in the last 15 years or so, that has somehow fallen out of fashion. But one of our main philosophies where I work is to utilize internal mirroring as much as possible. So our internal mirrors are based on Cobbler, if you could believe it. There's an application called Cobbler. That's a provisioning system, I believe it was written originally by Michael DeHaan of Ansible fame. Excuse me. So internal versions with that second line item, internal versions are only updated after passing tests. We have a rigorous CI/CD cycle. We build our own packages internally for internal applications. Not everything is built as an RPM. The vast majority of stuff is now containerized, but there are still applications that don't run well in a containerized environment, so they're built as RPM packages and delivered. So our security and our level 2 support teams are the responsible parties for handling critical updates in terms of zero-day patching, emergency kernel updates and so forth. My team that I manage is only 10 folks. Our level 2 team is like 60, so they get to handle a lot more of the grunt work than we do. Another major thing that we focus on is swap-in updates where possible. So this is something that we kind of took from the cloud world, where if I'm going to update something, I'm just going to spin up a new thing and then point my networking routing to that new thing, and then it's good to go. I don't have to worry about the old thing can just fall away. This provides the dev teams the ability to A/B test the update cycle, so we're not kind of like praying that an in-place upgrade works or not, or breaks something. This is a very stable way to do it. I mentioned before, we package internal company tools as RPMs, and we use a pretty battle-tested config management system based around SaltStack. I have monthly talks with my friends at Red Hat about switching to Ansible. It's in the works. Eventually it will happen, but we are pretty married at this point to SaltStack for the near future. Yeah. So the important thing to note, this last part. We were doing all this stuff, minus the security level 2 stuff initially, before CentOS Stream ever existed. When I got hired in the company, CentOS 7 was just released as the Unix system of choice. And I should also preface, we're not only using CentOS Stream in our production systems, we have Red Hat licensed components where they're required. So here's the scope. We are basically an on-prem company. We have a little bit of stuff in the cloud, and every cloud vendor that there is, we have a little bit of stuff there. But the majority of the things that we run are running in multiple data centers within the US. And our virtual machine size kind of varies. And I know it's actually one thing right now, I checked last night, we're at 6,200 VMs, and it kind of just grows and shrinks depending on the needs of the devs. We're 1,200 physical machines at this point. That's not right either. And mainly our physical systems are running database applications like Single Store. I don't know if anyone's heard of MemSQL or Single Store. We have a really huge back of that application. Tens of thousands of container deployments. We have Kubernetes. We have Docker Swarm. It is what it is. Multi-cloud presence, like I said. My team is also responsible for assistance in OT real-time and OT security deployment. So that's things like sensor technology, telemetry, field device deployments using edge-type devices, or IoT devices, if you will, running CentOS Stream on like Intel NUCs, or things like a Fitlet, Raspberry Pi, those kind of things. So this is how our patching looks. Part of the whole way this operation works in a maintainable fashion is the mirrors are actually pinned per quarter. So our production workload updates in lockstep with the quarter. So we just had October 1st just passed. That is the start of Q4. We have a whole subset of automation that kicks in place that refreshes the mirrors October 1st. We have automation that kicks in that builds our custom internal images using a technology called Koji with the Kiwi plugin. Production VMs are patched and swapped in place. Like I said, with the level 2 folks, they handle that. In addition to that, we have a nightly build. So we also do nightly builds every single night where we refresh the package repository mirror every single night. And we have a battery of CI/CD tests that run against the very new latest image, which contains theoretically newest packages that are released. Because in CentOS Stream, the packages are not all bundled and released on a point release. They're trickled out, kind of like streaming, like a lake, I guess. Some days you get 2 updates, some days you get 3, some days you get none. It just depends. We also utilize a sandbox VM component, which are based on these nightly builds. This is like we give a dev a machine to do whatever they want to do with it. This is a short-term lifecycle system that they may have possession of for 6 months or so to POC test anything they like, build their own Kubernetes cluster if they want it. These things are automatically updated every 15 days, and they reboot every 15 days after the update no matter what. It's part of the schedule. Okay, so the question invariably comes up. You're running CentOS Stream. What vendor supports CentOS Stream? These guys. Thank you, Tom, for these guys. CrowdStrike. Who here uses CrowdStrike? Okay, well, I expected to see more. CrowdStrike, I know a lot of you, if you don't know who CrowdStrike is, a security company. They were famously in the news a while back for stopping the world. Look it up. CrowdStrike, Falcon sensor, which is what we use in our, I guess, our IDR systems, that works perfectly fine in CentOS Stream. With a caveat. The caveat is a specific kernel version has to be newer than the release requires a specific minimum kernel version, which that threshold was surpassed like a couple months back. So anything that's deployed in CentOS Stream 9 or 10 now should work with CrowdStrike without any problems. Rapid7 is another security tool. I think we use it for inventory purposes. Tenable is I guess a scanning system. Elastic-Seam, that just works. We just deployed Elastic-Seam like a couple weeks ago. Pretty straightforward. We do a lot of geoscience work, and these 2 particular vendor applications work with CentOS Stream. We have some other applications that I'm not allowed to just divulge what they are, but those are running on Red Hat Enterprise Linux. Open source stuff. This works. I've not seen at any point in time that these have not worked. They just work. And it's open source. So this is kind of this is a typo. This Elasticsearch, we think of what's Elasticsearch down here and what Elastic's up here. It is the same company, Elastic. The open source for this method is, or for this product, is a specific application called Elastic ECE. I don't remember what the acronym stands for. But they have officially stopped supporting CentOS Stream. Well, guess what? That one's in a row now. Not a big deal. And I'm going to skip over the HashiCorp suite, sorry. All right, so what we do is we, like I mentioned before, we package a lot of RPMs internally. We use our upstream tools, the upstream tools provided to us from the Fedora community as much as possible. So this means we have an internal Koji system. We have an internal dist-to-git system, Cobbler, as I mentioned before. Fed package and Fedora review, these are provided directly from the upstream community. Am I talking too fast? I feel like I'm going through this really rapidly. I have a lot of time to fill. Okay. So these tools basically allow us to build, test, and deploy our custom internal applications using the same tools that are provided upstream. So it's not an accident that we're doing this way. My team has 10 individuals on it. The main reason that we're utilizing the exact upstream tools that are done in Fedora and CentOS and theoretically Red Hat is because I want my engineers to be able to parlay their internal working experience to step right into a role in the community and provide package support directly to the community. So the same methods and ways that we build packages internally, it is literally 99% the same as the way you would be a package contributor. So that's the reason behind that. So this is a look at our internal dist-to-git repository. You can see a couple of we built around 150, 160 source packages internally. So a lot of stuff, this interface, if you're not familiar, this is cgit. Because of the special characteristics of the way dist-to-git works, it cannot be set up in something like GitHub, for example. Like, it's not possible. So cgit is basically a web front end that just runs a Git server in the background with a dist-to-git look-aside cache. I can go into details on this stuff if you want after the talk. I feel it might be a little boring to talk about during the talk, but let me know. As you can see, there's several packages and there's a lot more that we deal with. Our internal review process is modeled after the Fedora package review process. So when someone says, hey, I want to build a package, and how do I review it? I simply point them to the Fedora package review guide. Just read this guide. Now there are some differences in the way we as a company provide guidelines on package stuff, and that's mainly around certain components that would not be allowed in Fedora. For example, closed source package components, Fedora does not allow that. Certain binaries are not allowed upstream, but we allow them internally within our company. And this is just a quick and dirty view of the package ticket system. And this output here is from Fedora Review. So this is run internally on a package. I can't remember which package it is, but it might be one of the. So we build like 7 or 8 different Prometheus exporter extensions. This might be one of the Prometheus exporter reviews. There's a listing of the technology that we're using. I don't know how exciting this is. Yeah, thank you. I mean, Netscaler is pretty exciting. We had an outage last week. That's why it's so exciting. CentOS Stream jobs. Where can you get a job working with CentOS Stream? Is anybody hiring? That's a joke. Okay. So anyway, this is a listing of the jobs that we're in, nightly, quarterly, what have you. This is what we're using to do our battle testing of our environment. Now, when we ask, it's 2025. What the hell are you doing in Jenkins? I get it. I understand that. Jenkins provides some functionality that is not easily able to be duplicated in, for example, GitHub. I like GitHub Actions. It can't quite do some of the things here. So it is what it is. So one of the big jobs is the nightly repo updates. As you can see here, there's a listing. You've probably all seen Jenkins before. This thing just runs every night, 1:30, 1:29 a.m., refreshes the repositories for the nightly repos. Here's what that looks like. As you can see, the company is backed out. So, I hope it is. It should be. Anyway, so this is basically, this is a CentOS Stream latest. So we label our mirrors like latest and stable, basically. So this is just up to date. I took this on October 1st. Okay, image canary is a very interesting thing. So, internally we use a system called Kitchen CI. Give me one second. Kitchen CI basically will deploy a virtual machine. Sorry, wrong slide. I got ahead of myself. This is the image canary build is used by Koji and Kiwi to create basically a QCal image that we use for our daily work. So all of our configuration management code that we write, salt formulas and whatnot, that's all done through Kitchen CI. This is part of the build component. So we build a nightly build of the nightly snapshot of packages from CentOS Stream, package it up as a QCal, and dump it into Cobbler. The engineers then download that image to their laptops or their machines and run their kitchen tests on that. And it happens every night. As you can see, there's a couple other things. You see a Darktrace OT and a real-time edge at the top there. Those are live install custom images that we use. Those are the OT components that I spoke about a minute ago. Those are deployed on field devices from Raspberry Pi to whatever field device they have. Salt stack config management. God bless it. This is the core component of how we deploy systems. We have approximately, 250 separate salt formula GitHub repositories, which is a small sampling of the ones here. I don't know if you've ever managed multiple Git repositories to design a single product. It is pretty intense. It may not be the best solution for us, but it's the solution we have right now. It definitely has some shortcomings. Anyway, these are the things that we have like a nice quick sampling to see, like, okay, whatever's in Yum failed last night for whatever reason. We know it works in one of the current CentOS versions, -10. I'll get to 10 in a second. So we can see that this is basically sends an alert to team channel, a Teams, Microsoft Teams channel. One of the engineers goes in, doesn't look, hopefully fixes it. And this is like this is a drill down view of one of the workflows from here, just showing the history of the nightly one. Well, let me go back. Kitchen CI. So I have packaged up Kitchen CI in a copy repo. If anyone is ever interested in this, that's the links at the end of the slide if you're interested. It's a really interesting product. I think Facebook is one of the biggest users of this thing. It's pretty cool. It was written by the Chef folks. So I'm just going to give those guys a shout out. ISO builds. So part of our deployment strategy is to create ISOs that are automatically distributed to our VMware data stores so that when a request comes to deploy a VM, This might sound complicated and confusing. It's basically, it all funnels through SaltStack. SaltStack will send a command message to VMware to deploy VM. VMware is pointing at a seeded ISO that is just basically has a kickstart value in it that points to Cobbler that generates the system. Completely up to date, and once it comes up, it's done. You don't have to mess with it. It works pretty well, but it is a little slow. Okay, so testing nightly builds. So every night, we test our core component, which is based around 15 salt formulas, which would, I guess, that'd be equivalent to an Ansible formula, Ansible. So it combines these 15 together. Because they're separate repositories, they're built and configured and tested initially individually, but the nightly test combines them all and to verify that there's no cross-contamination between, like a change in the one repo doesn't affect another change in another repo. This just guarantees us that we have continuity between the base builds. And this runs every night. It's triggered by the repo updates, and it's also triggered by the image canary build process. It runs really quick, and it lets us know. It also lets us detect things like CrowdStrike failures. So, certain versions of CrowdStrike, and I don't mean to dump on CrowdStrike. It's just within the last few years, we've caught 3 CrowdStrike updates that have caused things to not work. We can clearly see this. If the machine starts to boot up and CrowdStrike's installed and it seg faults, well, I know there's a problem because I can't run the test fail. So that helps us a lot. Yep. Well, yeah. Yeah, that was, yeah, because that affected all the airlines, I think. So here's a crudely put together, gosh, I did not write this slide. It looks like it was done in Microsoft Paint. I apologize for that. It's kind of how it goes together. So we use Lorax. You may not be familiar with Lorax. Lorax is an internal product that we use to create the ISOs. We're going to replace it with Kiwi. We've done all the image stuff with Kiwi. It's just a matter of time to replace it with Kiwi. There's our SaltStack configuration engine that connects to VMware. Cobbler is probably one of the most important parts of this because it does double duty as a repository mirror and kickstart server. I'll be honest with you, I've been at this company for 8 years, and Cobbler has never once gone down, not once. It is probably one of the most rock-solid pieces of software that I've run. Our Kubernetes cluster, on the other hand, if you look at it when you good luck. So, I have burned through really quickly. We have a lot of time left, so I'll try to talk slower. What are future improvements that we can make to this? We don't have a good way to test cluster installation automation. Right now, the things that we're testing are based upon individual units, which are individual VMs, for lack of a better word. I'm open to feedback if anyone has any ideas of a way to do that. I personally don't know of a way to do that at this time. But this is something we're looking into. And this is mainly in regards to things like Redis clusters, I guess RabbitMQ clustering. There's a few others that I'm skipping my brain right now, I can't remember. OpenQA would be awesome. But OpenQA, first let me explain. OpenQA is the QA system that the upstream OpenSUSE and Fedora are both using to test installation of their install media. We would utilize this to help test our live media installations and possibly do some more aggressive testing with security updates and CrowdStrike things. It would be lovely to have this. we've been working with the upstream folks for a while to get this into CentOS stream. And one of my SIG colleagues, Davida Kavalka, is working with some of the CentOS integration folks to get this to happen. Hopefully it happens next year, I think. We'll have to double check the minute. Oh, dist-git. So, this thing is, the upstream Fedora folks are eventually going to migrate away from Pagure. I'm not sure if anyone here is familiar with the upstream workings, but Pagure has been deemed, they're just going to leave it be, they're not going to improve it anymore. Fedora is using something right now called Flojo, which is an open source fork of Git-T. It looks really nice, really good, but they currently don't have dist-git working with Flojo. And as far as my understanding, they're still looking for ways to make dist-git work, and they might actually switch dist-git to use something like Git LFS or some other mechanism. We'll see how that goes. This is the big one. So, integration with ZeroCI or similar product for cross-project testing. Like I mentioned before, we have 250 separate salt stack repositories, equivalencies of Ansible roles, that some are cross-dependent across multiple different repositories. This creates a problem. If, say, someone merges something before something else, you can get like weird behaviors. ZeroCI would be able to prevent against this by adding comments into your pull request so that Zero becomes the arbiter of a dependency. Say for repository A, there's a pull request, you add a comment, this is dependent on repository B, pull request number 15. So as soon as repository B, pull request 15 gets merged, Zero comes back and merges repository A. We need this desperately because there's a lot of problems that happen when you have 250 separate repos. Any questions? I know this is kind of a very fast run through. Any questions?
Yeah, I saw a little bit of that HashiCorp stuff, so I was just curious what your console and vault happening, what that kind of looks like.
Okay, so the question was, do we have console and vault in our environment? And what that looks like in our environment, right? So yes, the answer is we have both. We use both. We basically mirror. So the slide actually was written when HashiCorp changed their licensing to a source available license for a split second, and they switched it back. So, but I thought they switched it back. You know what? I might be incorrect on that, but the point is there's some kerfuffle about the license changing around Vault because other providers or service providers were selling Vault as part of their products. HashiCorp changed the license so that to force them to either pay licensing fees or not use it. We don't currently have any products that we're selling externally, so we're safe from any kind of licensing problems like that. Same thing with Redis, but Redis, okay, I got confused. Redis source available license did change. They moved to a source available license and they moved back. So I remember when that happened, there was like a debate amongst the internal teams. It's like, oh, if we're ever going to sell a product and we're using Redis as the back end, this license is not compatible, you're going to have to pay a fee, and then they switched it back. So yes, we use console and we use Vault. We actually use Vault with the console backend. Our salt stack deployment actually uses console as an external pillar, which is basically an external metadata store that describes the outcome of the system, basically. So we provide a role, contact information, any sort of secret information, secrets that are related to a system are stored in its console entry. This is how we deploy our systems. This is how we know what they will become. So if I want to deploy what's a good one? A RabbitMQ system. So I will go to my deployment system, type in the role of RabbitMQ, type in the contact as the the group contact for that system, punch go, and then 5 minutes later, 10 minutes later, I'll have a system built, configured, ready to go, that's running RabbitMQ. I don't have to touch it. And the person that needs access is in the contact email group. They automatically get AD access because we use Active Directory. So they can log right in and they have permissions to do what they need. We've done pretty good from when we first started. Everything was handled over, and there was a lot of hand-holding to get systems set up, which was very detrimental at first. But once we started having folks contribute and to write the formulas, it became a much easier thing. So what we've basically taken what's been like a day-long process to 15 minutes, essentially. Part of the other components that we have that I didn't really go over too much is our Kiwi build system actually builds our images for our Kubernetes workers. So we're a pretty large consumer of Kubernetes. I think we're running around 4,000 or so pods on a daily basis. We average around 150 to 200 services internally. So all that stuff is running CentOS Stream. Every last bit of it. Like I said, the components that are required by vendors to have a certified, stamped operating system, that's running in well. So, any other questions? Carl, do you have a question? All right, guys. Well, I appreciate you coming to this talk. I didn't put my contact information up here because I had COVID for the last month, and I just realized my QR code didn't work. So I didn't even put something up here that didn't work. So if you have any questions or anything, just feel free to reach out to me in the hallway track, and have a great rest of the conference. Thank you, guys.